Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is database, meaning and types. After going through this course, the students will understand that data means raw facts, and when we process and transform these raw facts into meaningful facts, then it becomes information. We will also understand the difference between data and information. While the data may or may not be useful, information is always useful. Data does not depend on information, whereas information is obtained from the data. Data does not form the basis of decision making, whereas decisions are taken by the organizations on the basis of the useful data, that is the information. The students will also understand that database is a collection of relevant data. Then the students will also understand that there are some common types of databases such as the relational database, NoSQL database, object-oriented database, graph database, NewSQL database, in-memory database, time series database, etc. The students will also understand that relational databases organize data in the basis of tables where there are rows and columns. The relational database was introduced by E. F. Fogg, who was an English computer scientist. The students will also understand that NoSQL databases are suitable for unstructured and semi-structured data. The students will also learn that object-oriented databases store data directly in the form of objects along with their attributes, and the graph databases store objects in the form of graph-like structures. The time series databases store time series data. The students will also learn about the NewSQL and in-memory databases. The students will learn that DBMS works as an interface between the users and the database. And when a request is sent from the user, the DBMS processes this request and looks for the desired information from the database and sends the output to the user. Now the topic before us is data. Now we will discuss what is the meaning of data, what is the meaning of information, and what is the difference between data and information. First of all, we will discuss about data. Data refers to raw facts and or figures. Data is an unsystematic fact or detail about something. Suppose you go to a shopkeeper and give him in writing in which it is written 10. Whether the shopkeeper can conclude from your writing the word 10, what do you want? Whether you want 10 liters of oil or 10 kilogram of atta or something else. So this is data. This is the raw facts from which nothing can be concluded properly. The data is derived from the Latin word datum, which means something given, a given, or something that should be taken into consideration. Plural of datum is data. The dictionary meaning of the word data is facts and statistics collected together for reference or analysis. Data alone has no certain meanings until and unless data is explained and interpreted. It is just a collection of texts, numbers, words, and symbols. Here we will give an example. Suppose you have something before you in which it is written one Rihanna, $5,000, and then there are certain numbers. Can you conclude something from it? You can say that this is serial number, this is maybe the name of an employee or customer, this may be his salary or his account balance. You cannot conclude anything properly. This is data. Another example is, here a few words are written. Can you conclude something from it? No, we cannot. This is also a data. This figure is data. And it does not provide any meaning to us. Next, we have a set of numbers before us. $500, $1,000, and so on. These are also just figures. These are raw facts. These numbers are data, and they do not convey anything concrete to us. Now, we come to what is information. When the data is processed and transformed in such a way that it becomes useful to the users, it is known as information. Information is drawn from the data. Information is a systematic and filtered form of data which is useful. Information is free from unnecessary details or immaterial things. The raw data is analyzed, organized in such a way that only the necessary information of the data is kept and the rest of the data is discarded. The term information is discovered from the Latin word informere, which means to inform. Information refers to the meaningful data. Now, what we have given the example in our data, we are reproducing below the same in the form of a table. You can see here that this said information has been given in the form of a table where one is serial number, Rihanna is a name, and $5,000 is the salary per week. And these are the numbers which represent the mobile number of Rihanna or the contact number of Rihanna. We had also discussed about these numbers when we were discussing about data. These figures are only just data. But if we write that date of birth is 2nd Jan 1984, it becomes information because this information, this data shows the date of birth of a particular person. We had also discussed the figures of that is $500, $1,000, $1,500. These were just figures. We do not know whether these are the salary figures of different persons or the salary figures of a particular person for the different years or the bank balance of a particular person which a person is having in different accounts, or the bank balance which is increasing year by year of a particular person. So all these are just figures. We cannot conclude anything from that. These are just numbers. These are data. But when you analyze these figures in the context of a sales report, that is, if you prepare the sales report and these figures are shown there, then you can say that in the first month the sales figures are $500, and in the next month the sales figures have gone to $1,000, and in the third month the sales figures of the organization have gone to $1,500, and so on. Now this is the information which has been presented to us in the form of a sales report, and from this information you can conclude whether the sales of the organization are increasing every month, what is the average sales during all these months, and what is the total sales, and what steps you would like to take to increase your sales in the future. So on the basis of the information we can take decisions what as an organization we should do to improve the working of the organization. But if we have mere facts, only the data, only the figures before us which are not relevant to us, not useful to us, so we cannot take any decision on the basis of data. We have to take decision on the basis of the information, that is the relevant data. Information is utilized in some significant way, such as to make decisions, forecasts, etc. Now we will understand the difference between data and information. First of all, what is the meaning of data? Data means raw facts gathered about someone or something. On the other hand, information, when the data is processed and transformed in such a way that it becomes useful to the users, it is called information. Now, what is the form of data? Data is unorganized. It is randomly collected facts and figures. On the other hand, information is organized. When the data is organized, it becomes information. Information presents the data in a better way. Data may or may not be useful, but information is always useful. With meaningful data, that is information, the organization can take decision. Data does not depend on information, whereas information depends on data, because the information is based on the data. We process the data, we retain the useful data and discard the unuseful data. If there is no data, there will be no information. You cannot make a decision on the basis of data. On the other hand, we can make a decision on the basis of information. The examples of data are temperature readings 25 degrees Celsius, 30 degrees Celsius, 22 degrees Celsius. On the other hand, the example of information is average temperature this week 26.33 degrees Celsius. In the world of computers, data is the input, or what you tell the computer to do, save. Information is the output, or how the computer interprets your data and shows you the requested action or directive. Now we will understand about database and the evolution of database. First, what is the meaning of database? A database is a fundamental and indispensable component of information management. A database is a systematic and organized collection of data. This data is typically means generally. This data is generally stored and managed on a computer system. If we store and manage the data on a computer system, we can easily assess and manipulate information. Manipulate means we can add more data, make some changes in the data, or delete data. All this comes in the meaning of manipulation of data, manipulation of information. You can visualize a database as a container of information. In today's data-driven world, it would be very difficult to manage and use the huge amount of information without databases. So in this world of competition, where every organization has to deal with large amount of data or large amount of information, the use of database is very important or essential. All of us make online purchases or make use of online services provided by the banks. While doing online purchasing, we may visit the site such as Amazon or eBay. These sites or the organizations like Amazon have to store the data in respect of their customers, such as they have to keep the details of customers' name, email address, phone number, what is their shipping address, what is their login name, username and password. And when you order something, they have also to maintain the record of what is the order number, what is the order date, what particular items have been ordered, and what is the payment method, whether it is cash or it is on credit, or whether you have made online payment. They have also to maintain the information in respect of your credit card details, though they are not readable, they are in encrypted form. They maintain the detail of other payment particulars. When you are doing various type of searches on the particular website, the website also makes the record of the same in their database. When you are using the services of a particular organization online, that is the banks or Amazon or eBay, they also keep record of your subscription details, because all the times the services are not free. They may be charging something from you annually or on monthly basis. These organizations also keep track of your IP address. This is only for security or fraud prevention purpose. When any organization, whether it is online or offline, have to keep so much record, what type of particular products they are selling, what is the price of the particular product, customer details, seller address, this and all that, then all this information they have to store on a server as a database, because all this information cannot be kept in manual form. All this information is kept in the servers as a database. And when we are searching anything or ordering anything on any website, you are actually interacting with the database of that website or that organization, and you can add data to it. That is, you can make particular change in your address, residential address or shipping address. You can make some change in your mobile or contract phone number. You can edit the order placed. You may cancel the record order what you have put. You can order something new, or you can search any type of product which you want to purchase. So all this information which you are placing as an order, or you are editing your order, or you are editing your personal record. All this information is stored in the database. On the basis of this data, that is, you have changed your record shipping address, the database will record that change, and next time when you order, the order will be placed at your new address, or the information about your order placed will be sent to your new email address. And on the basis of various type of searches which you make on the any website, the organizations send you emails, and on the basis of that, the organizations can take decisions that particular type of product is in demand, and the particular product is selling more in the particular region, and there is a need to upgrade their servers or manufacturing facilities or all that. Now, what is evolution of databases? Since the 1960s, there have been significant advancements in the design, functionality, and use of databases. Functionality means functions. It means that since the 1960s, a lot of changes have taken place in the designs of the databases, functions of databases, as well as uses of databases. Initially means many decades ago, databases were simple and file based. That is, if we were to make any change in the data, we have to go into the relevant file to make that change. In the 1970s, the advent of relational model revolutionized databases. The relational model was introduced by E.F. Codd, who was a English computer scientist. The relational model introduced the concept of tables, rows, and columns. It means that the data can be saved in the form of tables where there are columns as well as rows. In the late 20th century, object-oriented and NoSQL databases emerged. These databases were designed to handle complicated data types and large-scale unstructured data. Unstructured data means social media posts, audio, video files, our emails. Because the earlier relational model was not able to handle or store and manage the unstructured files, unstructured data. Nowadays, databases can be spread across multiple computers. That is, we need not to save all our data in one computer or in one server. The database of an organization may be spread over many computers or many servers. They can do much more than before. Now the databases have much more capabilities or functionalities. Databases help us manage and analyze data in a better ways. Databases offer organized data storage. Over the time, databases have evolved significantly, improving their capabilities and functionalities. It means that the functions of the databases and the capabilities of the databases have improved significantly with the passage of time, because new and new developments or new and new technologies are being introduced. Nowadays, databases enable better information management and facilitate efficient access and manipulation of data. Now, the topic before us is types of databases. Now, we will discuss what are the various types of databases. We will also understand these types of databases with the help of real life examples. That is, what are those, which are those organizations, or what are those fields in which this particular type of specific database is being used. We will also understand whether one type of database is used by a one organization, it is sufficient, or whether the organization may have to use a combination of different types of databases. We will discuss all it in now. Now, first we will discuss types of databases. There are various types of databases. Each type of database is suitable to specific use cases and requirements. Now, these are the common database types, that is relational databases, NoSQL databases, object-oriented databases, graph databases, time series databases, new SQL databases, and in-memory databases. These are some common databases types. Now, first we will discuss relational databases. Relational databases organize data in structured manner using tables, rows, and columns. That is, if we say that this is the table, these will be the columns, and these will be the rows. If we say that this is the employee table, then it will be serial number, or first it will be employee ID, then employee name, address, then it will be salary per month, some other particular. This is the employee ID. These are the columns. These are the rows. So all the information which the organization may have to store, and it is using the relational database, the information is stored in the basis of these tables. The company may be selling different types of products, then product ID, its price, something like that will be mentioned in the tables. These type of databases follow a fixed schema, that is the fixed plan, where data types and relationships between tables are defined in advance. What is the data types? Data types means, in the case of employee ID, we can only add say 1, 2, 3, 4, 5, or the employee ID may be 5, 6, 3, 1. We here cannot add ABC. This is the data type. When we are writing about name, we will use the name, say Ila, Rahil. Here, in the case of name, we cannot write 1, 2, 3, 2, 3, 4, because these are not names. So there is the fixed data type which can be added or mentioned in the particular column, in the particular field. Here we can add only particular type of data. In the case of salary, we cannot write ABC. We will have to mention $1 to $3 or $5, $6, $7. So these are the data types, and we can add only the data type which is suitable to the particular column. So there is further, it is written that there is a relationship between tables. How the relationship is established? The relation, We take another example. Suppose there is an organization which sells various types of products. We may take the example of Amazon. These are, here it is the customer table. Here it will be customer ID, then it will be followed by customer name, address, then email address. Then there is order ID, order table. Here the information will be stored in the form of, say, order ID, then order date, products ordered, then here it will be the customer ID. So these two tables are related with the one ID, that is customer ID. This is the primary key in the first table, and it is becomes the secondary key, foreign key in the another table. Here it is foreign key, customer ID is here foreign key, here it is primary key. So the relation between the customer table and the order table has been established with the help of keys, that is the primary key and foreign key. Structured query language is most commonly used to interact with the database. Structured query language makes it easy to search, add, update, and remove data in relational database system. This type of database is commonly used in e-commerce platforms, financial services. Financial services means banks or non-banking companies, NBFC companies, where data consistency and well-defined relationships are crucial. Examples of relational database are MySQL, PostgreSQL, Oracle, Microsoft SQL Server. Now we make the mention of real life example of use of database, relational database. Relational databases are extensively used in banks so that they can organize and manage their financial data. The databases of the banks contain various types of tables. That is, the relational databases of the banks contain various types of tables, such as the customer table, where they contain the information in respect of their customers, such as their name, what is their address, what is their contact details, etc. Then their relational databases also contain accounts table, that is, what are the different types of accounts which are held by the customers. Relational database of the banks also have or manage transaction table, that is, what amount has been deposited by which customer, what amount has been withdrawn by which customer, what amount has been transferred by which customer. All these transactions have to be recorded in the transactions table. Then there are card tables, that is the debit card or credit card details, etc. The relationship between these tables is established using primary key and foreign key. As already discussed, suppose the bank may be having customer table in which it will be having customer details, and in the second there may be, say, transactions table. In the transactions table there may be transaction ID, transaction date, and there may be the customer details, customer ID. Or the relation may also be established with the help of accounts table, that is the what is the account number. On the basis of that, the relation is established between the customer table and transaction table, or customer table and accounts table. All this relationship between the tables is established with the help of keys, primary key, foreign key, or composite key. We will discuss about these keys in details later on. So all these tables which are there in the relational database of the banks are interrelated with each other with the help of keys. Now the next is NoSQL databases. While relational databases rely on predefined tables and relationships, NoSQL databases are more flexible. They store and manage data without a predetermined way of organizing the information. NoSQL databases are a good choice for storing and managing data in a variety of scenarios. These databases, that is the NoSQL databases, are flexible, scalable. Scalable means if the workload increases, the resources can be increased. These databases are flexible, scalable, and efficient, which makes them well suited for modern web applications, big data analytics, and scenarios where the data structure may change over time and require rapid scalability. That is, if the workload increases, data increases, the resources may be increased to tackle the workload. NoSQL databases are suitable for handling large scale and diverse data, including unstructured or semi-structured data such as documents, graphs, audio files, video files, social media posts, drafts, etc. Now the examples of NoSQL databases are MongoDB, Cassandra, Couchbase, Redis. Now we make the mention of real life example of use of NoSQL database. Social media platforms like Twitter, Instagram deal with vast amounts of user generated content. User generated content means the users of the Twitter and Instagram make many posts, they tweet, they post many images, videos, or comments on those platforms. All this data can be unstructured or semi-structured, which makes it difficult to store and manage in a traditional relational database. That is, all this type of data, whether it is audio files, video files, or other social media posts, all this type of data cannot be organized or stored with the help of relational database. Here the role of NoSQL database comes, which can effectively handle these types of unstructured or semi-structured data. NoSQL databases are ideal for storing and managing this diverse and evolving content. Now we discuss about object-oriented databases. Instead of using tables, rows, and columns like relational databases, object-oriented databases store objects directly along with their attributes and relationships. However, these databases, that is the object-oriented databases, are less common than relational databases and are often used in specialized domains. Specialized domains mean only in special fields like scientific simulations, computerized aid designing, or computerized aided manufacturing systems, and multimedia applications. The examples of object-oriented databases are ObjectDB and Versant. Object-oriented. Now we discuss about the real-life example of use of object-oriented databases. Object-oriented databases can be used in content management system of websites. In the content management system, various types of content such as articles, images, videos are managed. Because on websites, the users upload various types of articles, images, and videos. All these types of data has to be managed, and object-oriented database can effectively handle this type of data. Each content type, that is article, images, videos, can have different attributes and properties. That is, all this type of data has its own characteristics. For example, an article may have a title, content, author, and publication date, while an image may have a file name, size, and description. Object-oriented database is a good choice for content management system, as this database can store each type of content as a separate object with their attributes and relationships. Now, graph databases. Graph databases are designed to store and manage data in a graph-like structure. Graph databases represent data as a network of interconnected nodes, edges, and properties. Graph databases efficiently handle complex relationships and provide powerful querying capabilities. Querying capabilities means when you want to search anything, any type of data, and from the graph database will immediately provide you the relevant information. Now, the graph database are suitable for applications such as social networks, recommendation engines, fraud detection, and knowledge graphs. Recommendation engine means what? When you are making use of Amazon, you may search different types of products. Suppose you are searching the particular type of product, say jewelry. You are searching for the same for say 2-3 days, and after 3-4 days you will find that you will be receiving in your Facebook or in other social media platforms the recommendations related to the jewelry. How it happens? Because the companies or the websites make use of graph database. Services like Netflix and Amazon use graph databases. The graph database allows Netflix to track the connections between the users and the content they watch. This information can be used to recommend new content to the users as well as track their viewing habits. Now we will see another example of real life example of use of graph database. Amazon also uses graph database to store information about its products, customers, and orders. The graph database allows Amazon to track the connections between the products and customers. This information can be used to recommend new products to the customers as well as to track their purchase history. The examples of graph databases are Neo4j and Amazon Neptune. Now the time series databases. Time series databases are specialized databases. These are designed to handle time-stamped or time series data, where values change over time. Now, what is the meaning of time series data? The time series data is the data that is collected at regular intervals and has a timestamp associated with each data point. For example, we can understand the same. Say that if we are dealing with stock market, and in the case of stock markets, these time series databases are used. The time series database will store the data such as the price of a particular share of a particular company was such at that particular time. This is the time series data. That is the value of a particular share has been recorded, and the time of that recording of data has also been mentioned. What is the price of the particular share at particular time has been recorded, and this type of recording is done by the time series database, where the time is also recorded along with the data. To store data, time series databases often use compressing techniques to reduce the amount of disk space required. As the time series databases store data at regular intervals, the volume of data becomes enormous. So these type of databases use compressing techniques so that the amount of space required for storing that data is minimized to the extent possible. Now, what are the examples of time series databases? Examples of time series data are stock prices, exchange rates, that is the exchange rates of, that is the rate of the foreign currency also changes every minute. These trading volumes on the stock market also change every second. This type of data, that is the time series data, can be used to analyze market trends, identify trading opportunities, and manage risks. The new time series databases are designed which use cloud and artificial intelligence and machine learning technologies to store and analyze time series data. Now the examples of time series databases are InfluxDB, Prometheus, OpenTSDB. Now we here give the real life example of use of this time series database. The power plants are continuously generating a large amount of time series data or time stamped data. This data includes information about energy consumption patterns, that is, what is the consumption pattern at regular intervals, that is, whether the load energy is being used is at peak or the energy is being used at lower level, what is the power generation from various sources at different intervals of time, and what is the voltage levels at different intervals of time. All this type of data is generated by power plants. So the time series databases are employed to store and analyze this time stamped energy data efficiently. They help energy operators and analysts to monitor and optimize energy usage identify peak demand periods. That is, what are those times during which the consumption of electricity is at peak, predict energy needs, and detect any unusual patterns in power generation or consumption. Now, the next databases are new SQL databases. This is the category of databases that aims to combine the benefits of traditional relational database management system and NoSQL databases. These databases are designed to scale horizontally. What is the meaning of horizontally or scaling vertically? Scaling horizontally means to increase the resources, that is to increase the number of machines so that the organization can deal with the output, deal with the higher workload. It is scaling horizontally. If we say that scaling vertically means to upgrade a particular machine or a particular server. These databases, new SQL databases, are designed to scale horizontally. That is, the number of machines can be increased to deal with the increasing workload or increasing data load. Like new NoSQL databases, while maintaining ACID. ACID means these are the properties of relational database system. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. We will discuss all about this in detail in our subsequent courses. So these databases have the properties of scaling horizontally and also maintaining the ACID properties. The examples of new SQL databases are Cockroach DB and NeoDB. Scaling a database. What is the meaning of scaling a database? Scaling a database is the process of increasing the capacity of a database to handle more data or more users. There are two types of database scaling. One is horizontal scaling and the other is vertical scaling. In the case of vertical scaling, it means upgrading the hardware of a single machine or a single server, such as we can upgrade the amount of RAM, random access memory, CPU or storage space of one particular server or one particular machine. Whereas in the case of horizontal scaling, it means adding more servers or more machines or nodes to the system so that the increased workload can be effectively handled with. Now, we give the example of real life example of use of new SQL databases. New SQL databases are used in e-commerce industry, where a large amount of data is generated daily, including product catalogs, customer information, orders, and inventory levels. These databases allow e-commerce companies to efficiently manage concurrent transactions. Concurrent means simultaneous transactions. Handle real-time inventory updates. Real-time inventory updates means when you are purchasing something, immediately, and when you purchase a particular product, suppose the website was showing it as 60 products were balanced, and when you purchase 2 items of that product, the inventory system will immediately reduce the inventory to, and the website will show that the products balance are 58. These databases allow handle real-time inventory updates and ensure that the customer's orders are processed reliably. If the real-time inventory update is not there, then it may be possible that you make the order, you make the payment, but if the inventory is not proper and in not real time, that is the latest update of inventory is not being shown on the website, then a large number of orders may come from the different customers, and when the products are not there, the company will not be able to deliver the same. It will result in a lot of customer dissatisfaction, because the companies will have to feel sorry and will also have to indulge in unnecessary task of refunding the amount to different customers. So new SQL databases provide such benefits, that is, allow manage concurrent transactions, handle real-time inventory updates, and ensure that the customers' orders are processed reliably. Now, next is in-memory databases. These databases store data directly in RAM, random access memory, which makes them much faster than traditional databases that store data on disk. That is, here all the data in such type of database, all this data is stored in RAM and not on disk. These databases provide high speed processing, data processing, low latency, and real-time analytics, so that they are suitable for applications such as online gaming, e-commerce platforms. That is, these databases are used in online gaming and e-commerce platforms. Now the question will naturally arise, we are making mention of e-commerce platforms time and again, whether e-commerce platforms are using this particular type of database or the previous. In fact, the organizations such as the e-commerce platforms or social media platforms have to handle different types of data types. So the one type of database is not effective to handle or manage all different types of databases. So the organizations have to make use of different types of combinations of databases, so that they can provide efficient and better services to their customers, and so that the data is properly stored. Some of the well-known companies that use in-memory databases include Twitter, Facebook, Amazon, etc. The examples of in-memory databases are Redis, Apache, Ignite, Timestamp. Now, where they are used, these databases, they are used in financial trading platforms, because they provide lightning fast data processing and quick access to critical market information. The fast speed of these databases allows traders and analysts to execute trades rapidly and make timely decisions, giving them a competitive edge in the fast-paced financial markets. If you have any interest in the share market or stock market, you might have seen that when there is a news outbreak about a particular company reporting very good results, then when we see this on the television, we open our computer system and may start purchasing a particular stock. So the stock brokers or the financial analysts make use of in-memory databases, so that they can execute the trades rapidly and make timely decisions, because these databases give them the capability to execute trades rapidly so that they have the competitive edge as compared to the others. Now, the another question which we have also discussed somewhat earlier, whether a company sticks to one type of databases, the answer is no. A company does not typically means generally. A company generally does not stick to one type of databases. Different types of companies make use of different types of databases rather than sticking to one type of databases, because a company has to store the data or manage data not only in respect of their customer, but it also has to, say, Amazon or other social media platform may have to store or organize data in the form of, say, audio video files, social media posts, customers details, accounts details, other. So all these data types are different. So using a particular type of database, say relational database, may not be suitable to handle different data types or different types of data. Each type of database has its own strengths and its own weaknesses. A company may consider many factors while choosing a database, such as what is the nature of the data, what is the size of the data, what is the level of the performance they require, what are their scalability needs, whether they want to handle more workload in future, whether there is any whether we imagine that our workload will increase in future, in the near future. If we think so, then we will have to opt for that database which gives us the capabilities of scalability. Then the organization also looks into the cost consideration, which type of database is within the budget of the particular organization. What is the existing infrastructure? If the existing infrastructure is very out of date, the organization will naturally like to upgrade the same. What type of expertise is required? If the expertise is of very higher level, then naturally more skilled labor will be required to be hired for the same, and more budget will be required for the same. Then what are the industry specific requirements? All these types of points: budget, level of expertise, scalability, what is the type of data we want to store, all these types of considerations have to be taken into consideration while we are making a decision with regard to the use of particular type of database which have to be used by us in our organization. So there is no one size fits all. That is, we cannot say that one particular type of database is more than sufficient for any one particular organization. So any organization may have to use a combination of different types of relational databases on the basis of its requirements. Now we here give you an real life example of use of different types of databases by a particular organization. You might have heard the name of Airbnb. It is an American company. Many decades ago, the people were feeling a lot of problem when they were going for, say, on a tour to some foreign country or to some other place. They were finding it very difficult because the charges of the hotels were very exorbitant, and the customers or the people or the tourists were not able to afford the same. The company named Airbnb realized that there is a potential to cater to this type of customers who are coming for some short time at some distant place. This company created a new market, that is, they realized that there is a potential to tap this type of tourists or the customers. It created, say, a website, and it contacted the owners of the different or buildings who wanted to earn something, as they were having some portion in their house as vacant, and they were ready to give it on rent for some brief period. It collected the data of all these owners who were ready to give their accommodation for a temporary purpose to the tourists or other persons for a short period. Though at present Airbnb also is providing the facility of rental facility to customers, that is the long time stay. So this company allows the people to list their homes and other properties for rent to guests. It acts as a broker and charges a commission from each booking. Now, when the Airbnb at present, the Airbnb has a vast amount of data. Lakhs of owners listed on its websites, which are spread in different parts of the world. If you want to visit any country, you can visit their site. We are not promoting their site. We are only just giving the reference of the use of databases by this organization. Airbnb has to deal with vast amount of data related to property listings. That is, a large or thousands or lakhs of properties are listed, where they are located, what is the rent. Then if a particular customer approaches Airbnb site, whether he has booked, if he has booked, which particular property he has booked, user profiles, that is the customers profiles, reviews and more, that is the reviews which are being put, that is the different types of data Airbnb has to deal with. It is not, doesn't mean that the other organizations have not to deal with that. We are only discussing about a particular example. By using combination of different databases, Airbnb handles different types of data, because the organization may have also to upload the pictures of different sites or different properties. Airbnb provides fast and relevant search results to the users and analyze user interactions to improve their platform. Because Airbnb uses the different types of databases, it is in a position to provide better customer service to the customers. Now we will understand about the working of the database. First, what is the database? Database is an organized and collection of related data, and this data is stored mostly electronically in a computer system. Database does not keep the separate copies of a particular data file. Still, a large number of users can access the same data at the same time. For example, if you want to see the price of a particular product, and there are a large number of other persons also who want to say the price of the same product, say in the festival season, all the customers are interested to buy a particular product, that all the persons can, or most of the persons can access the same concurrently. The database is stored on a server. What is the server? Server is a computer that is dedicated to storing and managing the database. This is not a small computer. These are the very big size machines which are used for storing the data of organizations. The server where the database lies is connected to the internet so that the users can access the database from anywhere. For example, we do not know when we are going for online shopping, we do not know where the server is lying or where the database is lying on the which server. The server may be lying in your country or in some foreign country. All these servers are interconnected, and when we visit any or a website, we need not to think about the database or database server, and we are immediately shown the desired results which we want. That is, if we want to purchase a particular product, all the necessary details will be immediately flashed on our computer system, and we can access the database. Database means the information in respect of the particular product we can access from anywhere, from any part of the world. We can get the information by visiting a particular site. As shown in the diagram, now we are showing the working of the database in somewhat simple form, in picture form. These are the users, that is, we general people or the users. When we want something, we make the request. The request goes to the database system. Database management system or DBMS interacts with the database. Database management system finds out whether the particular information which the user is trying to search is available or not. If the information is available, then it tells this, it provides the necessary information to the user, and if the information is not available, then again search may be done to find out again. As shown in the figure, in the diagram, DBMS works as an interface between the users and the centralized database. Firstly, a request or query is forwarded to the DBMS, which works on the query with the available data. A searching process is started on the centralized database, and if the result is obtained, it is forwarded to the user. If the output does not completely fulfill the requirements of the user, then a rollback, again search is done, and again search process is performed until the desired output is obtained. It means that if you search a particular thing on a particular site and you are not satisfied with the reply given by the database or database management system, you can again search for the same, and again the database DBMS will perform the search from the database, and again the result of the same, whatever they find in the database, DBMS finds in the database, will be provided to the user. Now we will like to conclude this course. Data means raw facts which have been gathered about someone or something. When the data is processed and unnecessary data is discarded, it becomes useful to the users and it is known as information. Databases form the backbone of the modern information management systems. A database is an organized collection of related data, and the database is mostly stored electronically in a computer system. There are some common types of database types such as relational database, NoSQL database, object-oriented database, graph database, time series database, NewSQL database, and in-memory database. Each type of database has its own strengths and its own weaknesses. Whether it is structured data, flexible content, complex data, unstructured data, semi-structured data, there is a suitable database type for every situation. It is not that we can use a single type of database for every situation or for every type of data. As the technology is changing day by day, we can expect more specialized databases solutions to emerge. That is, we can expect and we should expect more specialized databases which we can see in future. Hello students, myself is Parminder Singh from Prab Kirpa classes. Our today's topic is DBMS, meaning and functions, database servers and its types. After going through this code, the students will understand that DBMS stands for Database Management System. Database Management System acts as an interface between the users and the database. Database Management System manages the concurrent access to data. The students will understand that the DBMS provides concurrent access to data by way of locking and transaction mechanisms. DBMS also provides controlled access to data. It means that the users who have the authority or the privileges to access and manipulate the data, only that persons can access the database so that they can make changes in the data lying in the database. Database management system has its various usages. It is used in the organizations like banks, railways, healthcare, manufacturing, and other fields. DBMS performs many functions such as data definition, data sharing and collaboration, data manipulation, etc. Data manipulation means adding data, deleting data, or making some other modifications in the data. DBMS usually stores data on HDD and SSD. DBMS is helpful to database administrators so that they can perform their functions properly. Database server is a specialized server. It acts as a centralized repository where various types of data can be stored. The database server, especially the modern one, can host and manage database of different types. Then there are various types of database servers such as centralized database server, distributed database servers, cloud-based database servers, and others. The centralized database servers are those where the database server is located at a particular location. Then there are cloud-based servers which belong to the third-party cloud service providers and they do not belong to the organization who is availing its services. The organizations can avail the services of cloud-based servers by paying rent or taking them on lease. Then there are distributed database servers where there are many servers who work in unison to provide a unified view of data. Now the topic before us is DBMS meaning and applications. Now first of all we will understand the meaning of DBMS. DBMS means database management system. Database management system acts as an interface between the users and the database. A database management system is a specialized software that helps the user to interact with the database. DBMS helps the users to insert, to delete, update, or retrieve the data. What is the meaning of retrieval of data? Retrieval of data means fetching the data. In other words, we can say that DBMS enables the users to fetch the data from database. DBMS helps in managing and organizing large collections of data efficiently. If we manage the data in the form of manual files, can we easily update or retrieve the data? If we want to locate any particular person in the file which is maintained manually, we will have to go through large number of files so that we can pinpoint the particular person which we want to find out. But in the case of DBMS, we can very quickly update, delete, insert, or retrieve the data. So DBMS is very helpful when we are to manage a large volume of data. DBMS allows users to concurrently access the same database. Concurrently means at the same time, simultaneously. In this picture, you can see that the different departments of an organization are accessing the database through DBMS. They are concurrently at the same time using the database. For example, the sales department may be requiring the information in respect of the sale to a particular client. Accounts department may be using the database for raising the bills or invoice. Zonal department may be updating the database in respect of an employee who has recently joined the organization. So that DBMS allows different users to concurrently access this same database for different purposes. DBMS, when multiple users attempt to update the same record in the database simultaneously, there is a possibility for conflicts, data corruption, or inconsistent results. What it means? Suppose there is a system for booking of hotel accommodation. Two separate persons have been interested with the job of booking. One person may be trying to update the system that the particular room is available for booking. He may try to book the same for some client, while the another user or another staff member of the hotel is trying to update the record or update his system showing that the particular room of the hotel is under maintenance and cannot be booked. The normal system may allow to updation of both the records. That is, it may show that the particular room of the hotel is under maintenance, or it will also show that the same is available for booking. That is, it will result into inconsistent record. If the said room is booked in the name of a client, it will result into inconsistent record, and it may ultimately result into customer dissatisfaction, as the customer will not be able to use that room when he approaches, because the particular room of the hotel will be not available for usage because it will be under maintenance. So to avoid such type of data inconsistencies or mismatching of record, DBMS role comes into play. The DBMS will lock the record so that only one user can update a particular piece of data at any given time, while other user can still read the data concurrently. We may add that DBMS uses two types of logs, or provides the facility of two types of logs, that is read log and the other is write log. We will understand or learn about the same, understand about these two logs in detail in subsequent courses. DBMS also uses a transaction mechanism to ensure that all the changes made to the database are committed or rolled back as a unit. What it means? It means we will understand the same with the help of an example. Suppose we want to purchase something from an online site. We go to the site, put our username, password, find out the particular product, and after selecting the product goes into the cart. We make the payment and the order is placed. The DBMS system automatically makes the changes in the inventory, and the order place is shown to you when you show your own account on the online store. That is the all the steps in this transaction. That is the searching of a particular product, placing of the order, making of the payment, then automatic updation of the inventory. That is, if you have purchased one particular product, the item will be automatically reduced. Suppose there are 60 items available on the online store and you purchase one, the DBMS system will automatically reduce one from the online showing, and it will naturally show as 59 because it takes automatic inventory. So all these steps which were involved in the transaction, in a single transaction, are committed means are updated, saved and permanent, are saved in the database. All the steps of the transaction have been are saved in the transaction. It means that the transaction is committed. It is permanently saved in the database. Another part is or rolled back as a unit. It means that if suppose we are booking a railway ticket, there is a central system, online system for booking of a railway ticket. We have searched the train and we have we are going to book one particular ticket. We are going to book a ticket in this particular train. When we are booking the ticket and we are making the payment, suddenly there is network failure or some technical issue either at our end or at the end of the online site, or there is some failure on the part of the banks in making the payment, the transaction is failed. So all these steps which we have taken, that is, we searched the train, we were going to be allotted a particular seat, all these steps are rolled back. If the computer system or online site was showing that there are 60 seats available and one seat was going to be allotted to us, but due to the failure of power or network failure, all these steps of the transaction which were involved in the transaction will be rolled back, and the original position will be shown by the database. That is, the system or the online system, reservation system, will start showing that the seats which were available before we started the transaction are placed in the same position. This means that if the transaction fails for any reason, the DBMS will undo all the changes that were made during the transaction. That it means that either the transaction has to be fully implemented or none of the changes which were made during the transaction will be saved to the database. By using locking and transaction mechanisms, the DBMS manages the concurrent access to data and ensures data reliability and consistency in the multi-user environment. Consistency means if suppose there are many users who are approaching the same website, all the users which are concurrently approaching the website will be shown the same result of a particular kind of product. If we are searching, suppose, a particular brand of oil, the website will show the same result to all the users. That is, there will be consistency in the information which is being displayed. It is all done because DBMS takes care of the same with the help of locking and transaction mechanisms. We will understand in detail about the locking mechanism, transaction mechanism, and the ACID properties of DBMS in our subsequent course. DBMS provides controlled access to the data. What is the meaning of controlled access? Suppose you are working as a branch manager in a particular organization. You will naturally have the access to all type of data regarding the working of your branch. That is, if you are suppose in working in a bank, you can see how many saving accounts are there in your branch, what is the name and what are the particulars of the customers, what are the various types of accounts which are being maintained by your particular client, to which clients you have advanced loans. That is all the information in respect of your branch relating to different aspects will be shown to you. But as a branch manager, can you access the higher level data, that is, which is of the regional office level, that is the one step above, or head office level? Can you have the same type of access? Can you see that how many branches are having what type of customers are there? If you are working in a head office, you can naturally open in your system, or you will have the authority to see where the particular branch is located, how many customers are there in a particular branch, how many deposits or how much loans have been disbursed by the particular branch. At a higher level, you can see all that, but at the lower level, you cannot see that. You will have a restricted access. It is only an example. This type of working or this type of controlled access is provided by the DBMS. It has to be ensured that as per our rank or as per the permissions or the authorities granted to us, we are given access to the system, so that there is no misuse of the data, or we cannot manipulate the data. DBMS provides controlled access to the data. It ensures that only authorized users with appropriate privileges and permissions can access and manipulate the data. Here, manipulate the data means we can insert the data. Manipulation means inserting of data, updating of data, deletion of data. It means, or this controlled access keeps the data safe from unauthorized access and unauthorized modifications. If you are having the access of higher level, you can naturally make some change. You can be in a position, or to avoid any adverse comments from the higher authorities, you will naturally make some changes that you are having higher deposits, but actually you are not having that deposits. So if you are given higher level access, then you will naturally do some unauthorized modification. You will be motivated so that you may not get adverse remarks from the seniors. So DBMS avoids all these situations and avoids unauthorized modifications, unauthorized access. DBMS is a computer-based record keeping system so that the data is properly organized and stored. DBMS facilitates the creation, maintenance, and use of a database. A database is an integrated collection of record, files, and other objects. We have already learnt in detail in our previous course about the database and the various types of databases. That is the relational database, graph database, in-memory database, and others. DBMS acts as a bridge between the users and the underlying database. When the user does any inquiry or makes any inquiry or makes any request, the said request goes to the database management system. The database management system searches for the result or inquires about the same from the database. The process of searching starts and the database provides the result to the database management system, and DBMS conveys the same to the, provides the response to the users. DBMS makes it easier for the users to work with the database without needing to deal with the technical details or of how the data is stored and retrieved. That is, we as human beings need not to worry how the database or DBMS works. We only go to the site, or in this competitive world, we many times or mostly do most of our work online. Whether we want to make online transactions, we want to make online purchases, then we need not to worry where the data is stored by the Amazon, or where Bank of America is having database server, how its DBMS system is working, how the Amazon is able to provide us the required result in a very fraction of seconds. So these are the technical details. All we need not to think about the same. We are to broadly understand the working of the DBMS and the database. Examples of popular DBMS are Oracle database, Microsoft SQL Server, Microsoft Access, MySQL, FoxPro, and SQLite. Now, use of DBMS for business activities or applications of DBMS. We give below some examples of where DBMS is used by organizations for their business activities in their day-to-day life. In the case of banks, banks use DBMS to manage customers' accounts, transactions, loan information, etc. That is, whether which customer has deposited amount, which customer has withdrawn amount, which customer has transferred which amount to which person. All these type of data is managed by the DBMS system in case of the banks. In the case of healthcare, that is the hospitals and healthcare providers also make use of DBMS to store and assess patient data such as medical records, billing information, and insurance claims. In the hospitals, there are doctors and nurses. There are also accounts department or billing section. Billing section makes use of DBMS so that it can store the data in respect of a particular patient about how much amount has been deposited by patient's relatives and how much is balance, whether there is an insurance claim which is to be got on behalf of the particular patient. Nurses make use of database or database management system to update the information in respect of the particular patient. Doctors make use of DBMS or database to see the patient record online. Educational institutions use DBMS to manage student profiles, course registration, and academic records. As you know that in case of many universities, there are thousands of students which are studying there. It is very impossible if manual system is adopted to make record of registrations, accounts records, the students' profiles. So here DBMS helps the universities or the educational institutions to manage all these type of records. Now this is the world of internet or telecom. Is searches are being used. There are millions of customers with any telecom service provider. They raises bills, have to maintain the records of each and every client. So here the telecom or companies also use DBMS to store and assess the record of customers, calls made, bills, how much internet usage or calls have been made so that the appropriate bills may be raised. So DBMS here helps to manage all these types of data of the customers. The railways use DBMS to manage the information related to passengers, reservations, cancellations, trains, etc. Because all the system is automatic, the DBMS effectively handles all the cancellations, new bookings, etc. Now the e-commerce companies such as Amazon or others, eBay, use DBMS to manage information in respect of their customers, employees, products, suppliers, and much more. Overall, DBMS is a crucial tool for efficient data management and ensures secure and structured handling of information. Now the topic before us is functions of DBMS. Functions or functionalities of DBMS. The functionalities refer to the various functions or tasks and operations that a database management system performs. The functions performed by the DBMS facilitate efficient and effective management of data in a database. Database management system performs many important functions We will discuss the same one by one. First is data definition. A DBMS allows the users to define the structure of the database, specifying the types of data to be stored, the relationship between data elements, and the constraints that ensure integrity. We will here understand the same with the help of an example. The library staff can define the structure of the database to store various information related to books, borrowers, and library transactions. How the library staff is in a position to define the structure of the database? Because DBMS allows this thing. The library staff can create a books table with various columns such as title of the book, author of the book, ISBN. ISBN means International Standard Book Number, availability status. The staff of the library can create a borrower table wherein the record of the borrowers is kept and the information such as borrower ID, name, contact number, and the number of books borrowed may be mentioned. Then the library staff can create transaction table wherein they can record the borrowings and return of the books. This table can have many columns like borrower ID, book ID, date of borrowing the book, date of return of book. DBMS ensures that library operations run smoothly. This is only a just example. In this way, the DBMS ensures that all the organizations which use the database management system are in a position to do their operations smoothly. Now the next function of DBMS is data manipulation. DBMS allows the users to manipulate data. Manipulation of data means adding of new data, changing the existing data, deleting data in the database. DBMS provides query languages such as SQL that allows users to do things like adding new data, changing existing data, deleting data in the database. DBMS also allows the user to ask complex questions about your data and get useful answers. Now we take a real life example of how a DBMS allows user to manipulate data. We here take the example of an online website which sells various products. The website uses the DBMS to store and manage product data, customer information, and order details. We take the example of eBay, where DBMS allows them to manage the data in respect of thousands of the products which are sold by them, thousands or millions of customers which they are having, and the large number of orders which are being placed every day on their site. Now the question arises whether all the persons are allowed by the DBMS to add data or delete data or do anything they like on the data stored in the database. No. In any organization, there may be a large number of workers may be working, but all the persons are not allowed to make changes in the database, to make changes in the data stored in the database. For example, there is online store, whether all the persons working in the organization can make changes about the number of products available online? No. Only some of the employees of the organization are allowed to make changes in respect of the product details. The website administrator can use the DBMS to add new products to the database. Here the word website administrator means website administrator or any person which is allowed by the website administrator can add new products to the database, because if all the persons of the organization are allowed to make changes in the data of the database, then it can result into inconsistency. Because if all the persons are allowed and suppose 100 products come into the organization and all the employees, now that 100 products have come, then all the persons may try to update the same, so it will result into inconsistency. So only the particular or few persons are allowed in any organization to manipulate the data. The website administrator can enter details like product name, description, price, and availability status. The information gets stored in the database and new products become available for customers to view and purchase. Now we take the example of customers. Suppose we mostly make purchases online and visit any online site. There we are having our login, username, password. So all the information such as username, such as our name, our address, our email address, our mobile or contact number is there. Suppose we change our mobile number or we change our residential address or office address where the products are delivered. So naturally we will like to change our email address or mobile number which we want to change. So the customer here has the authority to change to make such type of changes in the data of the database of the online site. If the customer wants to update personal details like shipping address or contact information, the DBMS allows him or her to modify this data. As a customer, we need not to approach the particular person of the website that we want to make change in our personal information. No, we can do it ourselves. The DBMS allows the same. When a customer places an order, what happens? Suppose we purchase one particular thing from an online site. The DBMS system, suppose there are 70 products being shown on a particular site of a particular product. When we purchase one, the DBMS system will automatically make changes in the database that only 69 are balanced because one has been sold. When a customer places an order, the DBMS automatically updates the product quantities, ensuring that the website never sells more product than it has in stock. Suppose there is only one product which the website is showing and you have purchased the same. Now any customer which is trying to purchase that product, the DBMS system will not allow it to purchase the same, as it will update the inventory and show that no product of that particular quantity of that particular brand or particular type is not available no more, hence purchasing cannot be made. DBMS ensures that the data is accurate, consistent and secure. Accurate means proper. Consistent means if this user is looking forward for a particular product on the website, it will see the same result. If I am trying to see for a particular product, for that product on the website, the system will also show me the same. That is the consistency of record. Next is data storage and organization. DBMS is responsible for efficient storing large volumes of data and arranges it in a structured format. By organizing data, it becomes easier to manage and retrieve data. Retrieve data means fetching the data. When the DBMS organizes the data properly in the database, it becomes easy that when the user wants to make any query regarding a particular product, DBMS immediately fetches the relevant data or relevant result from the database and shows the output or the required information or the result to the user. DBMS usually stores data on storage devices such as HDD, hard disk drive, SSD, that is solid state drive. Other storage devices are or maybe external hard drives, network attached storage, which is called NAS, and cloud storage, etc. Now the next function of DBMS is performance optimization. DBMS implies means uses various techniques and strategies to improve the performance of data retrieval and manipulation. It means that DBMS uses various techniques and methods so that the user is immediately in a position to get the result of his query, and the user is in a position to quickly make changes in the data, insert data, delete data, or other functions which he wants to make on the database. Some common performance optimization techniques which are employed or used by the DBMS are indexing, query optimization, caching. Caching means storing frequently used data in memory. Data partitioning means dividing data into smaller pieces. Compression means compressing data to save space, and other techniques. These were the performance optimization techniques which are used by the DBMS to improve the performance of data retrieval and manipulation. Next is compliance. DBMS enables or help the organizations to ensure data quality and compliance with regulatory requirements, because all the organizations have to comply with certain rules and regulations or law of the land or the laws which are applicable in their regions. So DBMS helps the organizations to comply with that legal formalities by providing accurate and proper data. Data sharing and collaboration. How the DBMS helps in data sharing and collaboration? We understand the same with the help of an example. Suppose there is a very big size hospital having the latest equipment in each and every respect. Here the DBMS plays a big role. How it plays a big role? All the information, medical record, what are the lab reports, what type of medication or medicines are being given to a particular patient, all are saved in the database. Now, if the patient goes to the doctor in this hospital, the doctor will see all the record online because all the data is saved in the database. So he will quickly diagnose or see what problem is there. He can provide immediate consultancy or prescribe the medicines. The nurses on their part can update the record about the medicines given to the patients which are admitted in the hospital. The pharmacist of the hospital will upload all the medicines which have been supplied or given in the name of the particular patient. The billing section of the hospital can see what are the medicines which have been used, what is their price, and can raise the bill accordingly. The billing section can also see whether there is any insurance claim which is to be claimed from the insurance company. If there is a lab section, there is always a lab in the hospital, in every hospital, most of the hospitals. Then the laboratory of the hospital will update all the lab reports instantly when they are ready on the system, and the database management system will store all the lab test reports in the database, and the doctors or the other staff can immediately assess the lab reports. So this is the data sharing or collaboration. Lab reports have been uploaded to the database, and the same are immediately available to the nurses and the doctors. So this is the data sharing and collaboration which this type of facility has been provided only because DBMS is there. DBMS enables data sharing and collaboration by allowing multiple users and applications to access and work with the same database concurrently, because when a particular information is uploaded or fed in the system, the same is stored in the database, and all the persons or all the users which have the authority to access the database, to access the data stored in the database, they can see the same. It facilitates data sharing across departments, teams, systems within an organization. Now the seventh point is administration and maintenance. DBMS helps people who take care of databases. That is, DBMS helps database administrators. How they help? DBMS helps DBAs by giving them special tools and utilities. With these tools, database administrators can do many important tasks, such as database administrators can create new databases, configure their settings, controlling who can access the database. That is, DBAs can decide, can make appropriate changes and decide who will have how much access to the database, making backups of the data for safekeeping, checking how well the database is working. So all these tools are provided by the DBMS to the database administrator, so that the database administrator can perform his work efficiently. This makes it easier for the database administrators to manage and maintain the database efficiently. Overall, DBMS plays a crucial role in modern information systems, as database management system manages data efficiently and securely. It enables efficient decision making based on stored information. Database management system enables organizations to make the most of their data. Now the topic before us is database servers. Database servers play a critical role in modern information systems. They manage and organize vast amounts of data. Here is a general view of the database servers. Database server is a specialized server. It acts as a centralized repository where various types of data can be stored. Centralized means at one place. All the data is stored at one place. Database servers are dedicated computers that hold the actual databases, and database servers run only on DBMS and related software. A modern database server can host and manage databases of different types, including relational database, unstructured, in-memory database, graph database, etc. Database servers are designed so that they can handle multiple user requests simultaneously. Database servers ensure that multiple users or applications can access and modify data concurrently. Modify means insert, delete, or make other changes in the data concurrently without interference or conflicts. The different types of database servers are available, such as relational database servers, NoSQL database servers, in-memory database servers, and distributed database servers. Database servers operate on a client-server model. Now we will understand the same with the help of an example. The website has a database server that stores information about products, prices, customers' details, and orders. We take the example of, say, eBay. That website or eBay site has a database server where all the information in respect of the customers, products, orders, and prices of the products, all the information is stored in the database server. When a customer visits the site, the user's web browser means Google Chrome, Microsoft Edge. The user's web browser, that is the client, sends the request to the website's server to search the desired product. That is, we want to search a product, we click it on the site, and the website's server searches the same. What website server does? It interacts with the database server, that is, which is called server here, to fetch the required data. That is, user approaches the website server and the website server approaches the database server. The database server in turn processes the request and provides the necessary information back to the website server. Now the website server does what? It displays the relevant data to the user. So what it is all? Client visits the website server approaches the database server provides the result to the website server, and the website server provides the relevant information or the desired data to the user. A database server is a combination of physical hardware as well as software. What is the meaning of hardware part of the database server? Hardware part of the database server means physical equipment like a computer or a set of computers that stores and manages the data. The key hardware components which are usually found in a database server are CPU, RAM, storage devices, HDD, network interface card, cooling system, server chassis where the servers are placed, etc. As the database servers do intensive data processing tasks, the data servers are doing their job round the clock. they have to do intensive processing. If you take the case of banks or online shopping sites, social networking sites, their servers are always busy because they have to handle large volume of data. In the case of social sites, tweets, various posts, audio files, video files, all this data have to be handled by the database servers. So they generate a considerable amount of heat. So proper cooling system like fans, heat sinks are crucial to maintain suitable operating temperatures and prevent hardware failure. If any system overheats, it fails. So prevent this system from overheating. The database servers have fans and heat sinks which form the part of the hardware of the database server. Larger databases with high traffic often require more powerful hardware. Naturally, if a large number of users are there or the database servers have to handle large amount of data, then naturally more powerful hardware has to be used to ensure smooth and efficient data management. The software of a database server is responsible for managing the data. This includes tasks such as storing the data, retrieving the data, retrieving means fetching the data, and updating the data in the database. Software components include DBMS, structured query language, database engine, security features, etc. Popular database server software examples are MySQL, Oracle Database, Microsoft SQL Server. The physical hardware and software of the database server work together to provide reliable and secure way to store and manage data. Now the topic before us is types of database servers. There are multiple types of database servers. We will discuss a few of them. First is centralized database servers, then distributed database servers, operational database servers, and cloud-based. First is centralized database servers. Here we have given the picture of centralized database server. It does not mean that it is actually placed in at the central place and the clients are located around it. It means that the server is located in a single location. This is a database server that stores all of the data for an organization in a single location, and all the users of that organization access the data from that centralized database server. They are commonly used, that is, the centralized database servers are commonly used in small to medium sized organizations, because these servers may not be able to handle the load if the amount of data increases. For example, if we take this example, suppose this database server is in a position to handle say 600 clients, but if the workload increases and the number of users or the employees in the organization increase to 1000, but the capacity of the database server is only to handle up to 7000 users. So the centralized database server is or may not be able to handle the load if the amount of data increases, or if the number of users or the amount of data increases, the centralized database server may not be in a position to efficiently perform its function. So next is distributed database servers. In this picture, you can see that these are the 3 servers. It means that the servers are located at different locations. They are interconnected with one another, and each server handles some portion of the data. If there is a problem with any particular server, say this one, it is having some problem and it is not working properly, then the working of the entire system will naturally get affected, and any request which goes to this server will be fail. There is somehow automatic system that that this server is automatically made to work properly, but many times the one particular or the other server which is the part of the distributed database server may not work, and it may require manual intervention. Manual intervention means the hardware may have to be changed, or the software of the hardware may have to be changed, or some other steps may have to be taken to get the work on streamline. Now we read what is written. Distributed database servers spread data across multiple servers that work together as a single unified system, that as a single server. Each server in the distributed database is responsible for managing a portion of the data, and they collaborate. They work in unison to provide a unified view of the database. As the data and the workload grows, more servers can be added. For example, if the number of users are increasing, so say here the users have increased or the data has increased, we can add more servers here, and all will be interconnected with each other. Say this here, more servers can be added in the distributed database server if the number of users or the database workload increases. Distributed database servers are preferred by large organizations with extensive data requirements and a large number of users. If it is expected that the number of users are going to increase or the volume of the data is going to increase, then the distributed database servers are the good choice for the organizations. In the distributed database, if one server goes out of order or becomes unavailable, the portion of the data it manages becomes temporary unavailable. Any requests for data residing on the downed server will fail until the server is restored or replaced. The performance of the entire system may be affected. Other servers might need to handle additional requests, potentially leading to increased response times. As the workload on the other server increases, if a particular server fails, then the response time will naturally increase. Automatic recovery and monitoring systems help mitigate the effects. It means that though there are automatic systems which take care of the after effects of such a situation, but in many cases manual intervention becomes necessary to resolve the issue and restore the failed server, and the steps to be taken may include hardware replacement, software update, or identifying and fixing any network related problems. Next is operational database servers. These servers focus on supporting day-to-day operations of the organization. These servers are designed to handle real-time data processing. These servers are operational. These servers are crucial, important for applications where data is constantly changing. In other words, we can say that these servers are useful in areas such as banking systems, e-commerce platforms, and online booking systems. Next is cloud-based data servers. From the name, it is clear that the servers are hosted in the cloud, but it does not mean that they are actually located in the clouds which we see in the sky. It means that the servers are not located on the premises, but they are located in the data centers which are owned and operated by third party cloud providers. They are accessible via internet. That is, these servers can be accessed via internet. Customers or organizations which want to avail the services of the cloud-based servers can avail the services on rent or on lease from the cloud service providers. The cloud service providers take care of hardware maintenance, security, backup, and other operational tasks. It may be possible that the organization does not want to take the headache of maintaining the hardware or software update or other technical or other problems which may be involved in purchasing and maintaining own database server. So they may think that a huge amount in the shape of cost may have to be incurred to purchase a database server, and maintaining it will also require budgetary allocations. So keeping in view the various such points, some organizations deem it fit to avail the services of cloud-based data servers whose services can be availed on rent or on lease. Examples of cloud-based service providers include Amazon Web Services, Microsoft Azure, Google Cloud, etc. The best type of server. What is the best server for an organization? It will depend on the specific needs of the organization. If an organization wants that it needs to share the data across multiple departments, it may use centralized database server. On the other hand, if an organization expects that its workload will increase very shortly, or it needs to improve scalability, then it will naturally use distributed database server, because if it is expecting that users will increase or that the database is going to increase enormously, it will naturally use distributed database server so that it can use or add more servers to the system to take care of the additional workload. On the other hand, there may be some other organizations who want or who need to store and manage vast amount of data. They would like to use operational database servers. Then there are some other points also which need to be considered while choosing a database server. That is the size of the organization. A large organization will naturally like to have a very powerful database server as compared to a smaller organization, because the smaller organization will naturally have to deal with only lower number of users, and it will naturally have to deal with lower amount of data. Then the other point is type of data. A database server that stores structured data will be different from a database server that stores unstructured data. Structured data means the data follows a structure, that is in the form of a particular tables, where there are rows, there is a particular structure. But there are other types of data which are called unstructured. Unstructured means audio files, video files, social media posts, emails. They do not have any particular structure. This is unstructured data. So to handle the structured data or unstructured data, the database servers are different. Next point is budget. If we want a very powerful database server, so the budget will naturally have to be on the higher side. But if we want a less powerful database server, less powerful, because we have to handle only few users, or our requirement of is of only a small amount of data that needs to be handled by the database server, we will need lower level of database server which is in a position to handle only a small data. Now we will like to conclude this course. DBMS stands for Database Management System. DBMS is a specialized software that helps the user to interact with the database. Database management system performs many functions such as data manipulation, data storage and organization, data sharing and collaboration, and performance optimization. Database management system is used by organizations to manage and assess their data. DBMS usually stores data on storage devices such as HDD and SSD. Database server is a specialized server. It acts as a centralized repository where various types of data can be stored. We can store unstructured, structured data, and other forms of data on the database servers. Database servers come in various forms such as cloud-based servers, centralized servers, distributed database servers, and operational database servers. Each type of database server has its own qualities, which is tailored to specific needs, and they provide diverse benefits to the user for efficient data management and accessibility.